I'm Anil Kumar. Welcome to my series on integration. We are looking into integrals of functions where the derivative of the denominator is the numerator. In that case, we have learned that the integral of such a function will be ln absolute value of the denominator plus c. We have few examples here which are related to this particular theorem. In this video, we'll look into 3 examples where we are given the integral. We kind of have to prove, right? So the questions for you are, prove that the integral of secant x is ln absolute value of secant x plus tan x plus c. Prove that integral of cosecant x dx is ln absolute value of cosecant x minus cotangent x plus c. And you need to prove that the integral of cos 2x over cos x plus sin x whole squared dx is ln cos x plus sin x plus c. You can always pause the video, answer the question, and then look into my suggestions. Now let me provide you with the derivatives of our trigonometric functions. So you know derivative of sin x is equal to cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Derivative of cot x is minus of cosecant square x. Now let me write down here derivative of cosecant x is minus cosecant x times cotangent x, and derivative of what is left? Secant is left, right? So derivative of secant x is secant x tan x. Perfect. So these are the 6 derivatives of our trigonometric functions. You need these derivatives to really solve the integral questions, right? So you have to be good at it. Now let's take up the solution of these questions one by one. You can always pause the video, answer, and then look into my suggestions. So the very first one here is we need to prove that the integral of secant x is ln secant x plus tan x plus c. Now whenever you see that the integral is ln of something, that means that this function should be in the denominator, right? And the numerator should be its derivative, correct? So think like this. Let us say if I have t as equal to secant x plus tan x, in that case, what is dt equals to, right? So derivative of secant x is secant x tan x, and derivative of tan x is secant square x. Correct? We could actually take secant x common, and what we get here is tan x plus secant x dx. So that becomes dt. So that gives you an idea, right? So the idea here is to multiply and divide the given function by whatever is there within the logarithm to get the result. You get the idea, right? So we can write down that the integral of secant x is equal to integral of secant x times whatever is given here will multiply and divide by this function, which is secant x plus tan x over secant x plus tan x. Does make sense to you? Dx. Now we have already seen that the derivative of the denominator is exactly the numerator, and therefore we can write down our result, right? So we know now that this integral can be written as 1 over t dt. If I substitute t as secant x plus tan x, then the derivative is the numerator. Perfect. So the integral can now be written as 1 over t dt, whose integral will be what? Will be ln t, absolute value, plus c. And in our case, t is secant x plus tan x, correct? So we can write this as absolute value of secant x plus tan x ln of this plus c as the integral of the given function. Is that clear to you? So whenever you have to prove like this, the strategy here is to multiply and divide by what you find within ln. Perfect. So exactly same strategy we are going to apply in these questions. So now in the second question, let me approach in a different way. We need to find the integral of cosecant x dx, right? Since we are given that it is ln of all this, the strategy is to multiply and divide by this function. So what we get here is we get cosecant x times cosecant x minus cotangent x over cosecant x minus cotangent x dx, correct? Now we'll make a substitution. Let t equals to the denominator, which is cosecant x minus cotangent x. In that case, dt is equal to the derivative of cosecant x, which is minus cosecant x times cotangent x, and the derivative of cotangent x, which is minus of this, so it becomes plus, right? Let me write full form. Cosecant square x, right? dx. So as you can see, this is the numerator, right? We can always take cosecant x common. So if I take cosecant x common, then what we get here is minus cot x plus cosecant x. Correct? So we can replace the numerator with dt. So what I get here is that the integral for all this is basically equal to 1 over t dt, which is ln absolute value of t plus c, which is ln absolute value of cosecant x minus cotangent x plus c. Is that clear to you? So that is how you could actually solve this question. I hope the steps are absolutely clear. Now let's take last example on this strategy. This time we have to prove that cos of 2x over cos x plus sin x whole square dx is ln cos x plus sin x plus c. Now you should understand what is the formula for cos 2x. Okay, so the integral which we are interested in figuring out is cos of 2x over cos x plus sin x whole square dx, right? Cos of 2x can be written as cos square x minus sin square x, correct? That is the formula. Over, we have here cos x plus sin x whole square dx. Now the numerator can be written as, this is difference of squares, right? So I could write this as cos x plus sin x times cos x minus sin x, correct? dx over cos x plus sin x whole square. Now you can simplify this by cancelling one of the common factors. So what we get here is integral of cos x minus sin x over cos x plus sin x dx. Perfect. Now you know derivative of denominator is the numerator, and therefore we can again write down the answer as we had been doing earlier. Correct? So now if I substitute t as equal to cos x plus sin x, in that case dt is minus sin x plus cos x dx. So which is cos x minus sin x dx. And therefore I can write down this integral as 1 over t dt, and that is ln absolute value of t plus c, or it is ln absolute value of cos x plus sin x plus c. Correct? So we have shown that the integral of the given function is ln absolute value of cos x plus sin x plus c. So I hope these steps are absolutely clear. So in case you get a question where you need to prove that this is the integral, and you notice that the derivative of the denominator is same as the numerator, or it can be made same, then that is a strategy to follow. I hope that makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.